Good afternoon and welcome back to our after lunch session. We certainly hope that you did have a good lunch and a good break and you're ready for the rest of our amazing conference sessions. Without further ado, I would like to introduce now our next speakers who are SNEHA KUMARI and EDUARDO TOLEDO, and both of them are from the Circular Chain Network in the USA. Snaya and Eduardo, over to you. And whoever starts first can please share screen. All the best.
Thank you. Thank you so much, Pearl. Hello, everyone. And Eduardo, if you could start sharing your screen. I'll start with a quick introduction about both of us. Um, um, Good morning, good afternoon, good evening, based on wherever you are listening us from. Thank you for joining us. We're super excited to be here and share a little about circular supply chains and how supply chains of 2030 will look like. My name is SNEHA KUMARI, and I am the head of industry trends from Circular Supply Chain Network. Eduardo, would you like to give a quick introduction about yourself?
Yeah, thank you, Sneha. So my name is Eduardo Toledo, but please feel free to call me Eddie. And yeah, I'm also from the Circular Supply Chain Network. I've been with the group for a little less than a year. This is when we started, but we gained a lot of traction in that less than a year. So happy to be here, and thank you for having us.
Thank you, Eddie. And Eddie will start the slides for us, and then we'll go over in more details about what circular supply chains look like in 2030.
Awesome. Let's get started. So I'm going to tell you a little bit of a story that happened 15 years ago, just off the coast of Australia on Christmas Eve. Here on this boat, not this specific boat, unfortunately, it's just illustrative. On this boat, though, there is a solo sailor called Ellen MacArthur, and she is on her way around the world alone. And at this point, she's several days, weeks away from local systems help, and so she's doing inventory on her boat. She's trying to figure out how much do I have when I return back to the UK, and so she had an aha moment where, just as the supplies in her boat fueling her journey were dwindling every day, she thought, "Gosh, it might be that materials on Earth fueling our economy are dwindling every day as well." So she turned back to the UK, started discovering that she is right. Supplies are dwindling, and it makes logical sense. But we're running out of
Eddie, just interrupt your session, please. Could you please move closer to the mic? We are struggling to hear you.
Okay.
Thank you so much, and apologies for the interruption.
No worries. Does this sound better?
A little bit better. Delegates, does that sound better? Eddie, could you continue talking, please?
Yeah. Awesome. No worries. So as I was saying, she turned back to the UK and started discovering that she is right. And the supplies are dwindling, which makes logical sense, but we're running out quite rapidly. So mineable gold, for example, less than 50 years left on the planet. And she started learning about concepts like cradle to cradle. And to learn about another concept, some time travel here.
Eddie, I'm so sorry. The sound still is a bit wonky. Is it possible to put on headphones, please?
Yeah, give me just a second.
We are so sorry about this and the interruption, Eddie.
No worries.
We're sure it's an amazing presentation and we don't want to lose any of it.
Right. Let me just connect here.
Thank you. Appreciate it. SNEHA, perhaps.
Thumbs up if you can hear me or not.
Wow, that is so much better. Delegates, is that better?
Awesome. Thank you. Thank you for letting me know. I apologize for that. So awesome. Right back to where I started. So 100 years, I was saying 100 years before a different Christmas Eve on 1924, on a side street here in Geneva, there was a meeting among business leaders, and they all have the same business, and they all had the same problem. They could not sell enough of their widget to stay in business. They're all running out of business. They're making these items, they're selling, but they're just not selling fast enough. Imagine in your mind, what could this item possibly be? It's the light bulb. So here we are in 1924, just coming out right in the middle of the second industrial revolution, and lighting is taking off, but just not fast enough. At the time, a light bulb lasted around 2,500 hours, and in this meeting, quite notable, the business leaders gathered all the major light bulb manufacturers in the world, and including GE was in the room, and they all decided to capitalize the light bulb from 2,500 hours down to 1,500 hours. This is important because this concept of planned obsolescence, that's what it's called. How do we plan something to become obsolete sooner? What's the balance? What could a consumer pay for? And at some point, it becomes garbage. And so this plan of obsolescence fueling consumption is the underpinning of today's economy, which we'll talk about in a moment. But historically, this is a very important time because it's just coming 2 years after Henry Ford coined the term mass production. So since then, for the last 100, 150 years or so, we've gotten quite good at making items, which you all know. And so this again is called the linear economy, in which SNEHA would talk about.
Thanks, Eddie. So since we are talking about linear economy, let's think about how our supply chains look like today. We typically take materials from our planet, we make it into a product, and then ultimately in this process, we create waste. And this is how we represent linear economy, but it doesn't have to be linear. It could be loopy, it could be circular. And in that process, we can actually think about how do we create value out of waste. So today we see it waste, tomorrow it will be value. And we'll go over that in more details in the slides coming up. Eddie, if you could go to the next slide. So what the Industrial Revolution did was actually helped us with mass ownership. So and it wasn't really bad necessarily. The middle class was able to afford and buy items, but was it really, it really had a downside. Did we really use as much of whatever we own? And that makes us think that how do we really become better stewards of the materials that we own? For example, if you look at this picture, Eddie, if you click next, about 92% of an average car spends about 92% of its life parked, which is a lot of time. And we don't realize that. But if you think about a model called Uber, where instead of selling cars, we actually sell transportation. And so in this process, we add economic value throughout the day. If you go to the next slide. Let's do a quick time travel. What you see right now here, it's 1970 and it's Denmark. A group of manufacturers wanted to find fresh water to use in their manufacturing processes. And the water that they were surrounded with right now here that you see is salt water, so which is not very usable. So what they did was they co-located and they put their factories next to each other so they could share the use of materials. And in this process, and it was made possible, and they're still running today. And during this process, they not just share water, but also energy and materials. And so collectively, they are now saving about $100 million per year. Eddie, if you could go to the next slide. And so in this process, as you can see, there is material security achieved as well, which is something that we all have been thinking about a lot. And especially during COVID, when we saw a lot of disruptions in terms of getting materials and overall in supply chain. So this this specific term of material security will become key year over year, because the elements that we are using from our global economy is dwindling, as Eddie pointed out in the previous slides. And it's important that we come up with a better way to exchange these materials. Next slide. Here, I would like to go over really quick about two types of materials that we will be talking about. The first one is renewable, anything that goes back in the biosphere. So the green side is renewable. It could be compost, energy resources, water, heat, anything. And the technical piece is anything that will not go in the biosphere. So metals, plastics. And we hope that someday in 2030, we talk about plastics as a renewable item, but today it's not. Next. And I would like to quickly go over this diagram. This is from Ellen MacArthur Foundation. It's called the butterfly diagram, and some of us might have actually seen this also. But what I want to show here is how this works is we want to keep the smallest circles as long as possible. So the green side that you see is where you see this area of cascades. So how much of this can be reused and send it back to our biospheres. And on the blue side, you have the technical materials where what we want to do is keep increasing the use of smallest the materials, and then maybe share it and keep being in that loop. Eventually, like, the recycling will be the last resort, as you can see here. But the idea is the wider the circle, the more resources it takes. And often the value of the material goes down and decreases. So we want to keep an item at its highest economic value. And as consumers, I would like to provide a fun fact, which was an electric screwdriver actually has a use life of just 15 minutes per day. And so if we think about, instead of owning an electric screwdriver by every person, if we had a tool library and we could go there and check it out and use it and put it back, we would save on so much material that actually goes in making that screwdriver and having every single person own it. So that's the idea pretty much behind how we could keep the materials in loops and increase the economic value. Eddie will go over the next slide for us.
Perfect. So before we take just another flashback, let us take our inventory hats and visualize this. If we considered Earth as a huge warehouse that we've been taking from slowly, making and wasting from, this warehouse is going to be empty soon. We're not refilling this warehouse. So just keep that thought as we move forward. So Deborah Dole, who was a pioneer in the topic of circular supply chains and who was a speaker here at SAPIX just yesterday, and also our lovely boss, who taught us everything we know, has a working theory that the circular economy is actually not possible at scale without the technologies of Industry 4.0. And since we are time traveling today, let's do the world's fastest recap of the Industrial Revolutions, which you're probably familiar with. So just as a refresher, this starts 250 years ago with the first Industrial Revolution. This was about steam and machines. 100 years after that, here we are in the second Industrial Revolution. This is about electricity and mass production. Along the ceiling there, you can see those light bulbs that were lasting too long and arguably got us into part of this predicament in the first place. 100 years after that, we get into the third Industrial Revolution. There's not as much written about this, but in the 1970s, about robotics and automation. A lot of the underpinnings of our industrial processes we have today really came out of the third Industrial Revolution. So about 100 years between the first and the second, and 100 years between the second and the third. And now just 50 years later, we're of course in the middle of the industry of 4.0. As you all well know, the sophistication of technology is the highest it's been. The cost of sensors in enabling the Internet of Things is quite low. We have more data than we have ever had before, and we are sorting out what to do with that. So we have this smart connected world and this idea about smart processes, which we've talked about. So If we talk about the needs to find and circulate materials, and this becomes the basis of a new marketplace, we replace today's commodities markets with the new type of secondary materials market. It'll probably still be called a commodities market, but instead of it being seeded with items from inside the planet, we'll seed it from items that have already been detached from the planet and are zooming around the economy today and perhaps in the landfill. At some point, we will mine those, kind of like in the movie WALL-E. In WALL-E, they go through and find value from what is thrown away. So today we think about the commodities market that's been through traditional mining, which I mentioned, and then we move on to something called urban mining, which is a fun one. So if we want to be able to find and repurpose waste as we see it today, we have tools for that. We can go to Gamble, we can go to Process, we can consider a value stream map and the purpose in that. But let's zoom ahead now to start looking at pieces of 2030 and what this all might come out to look like. Let's imagine what it would be like to be in a circular supply chain. We'll go through some practical examples and we'll leave you with a few more of that. I won't say fantastical because that seems a little too exciting, but a bolder idea of where we think the world is headed in these next 8 or 9 years. So let's go through 5 characteristics of a circular supply chain in which SNEHA will explain further.
Thanks, Eddie. So let's look at 5 key characteristics that we are using to define our supply chain. The first one is lean. Eddie, yeah. So I believe many of us are familiar with the concept of lean. Lean talks about finding and eliminating waste, while on the contrary, circular economy talks about finding and monetizing waste. So how how do we use less material, less energy, less water, less consumables to do the same tasks? And today we look at one process and see how we make it more efficient with lean by using less energies involved. In the circular economy, we will actually look at the full system end to end and see how do we use less overall, not in just in terms of resources, but also in terms of materials. Unfortunately, today in our current state, we are shipping items all the way around the world and then bringing it back. I mean, even if items like as fruits or berries that travel all the way from Asia to get packaged in Argentina to finally get into our hands so we could eat it. It's unfortunate, and the footprint that it leaves to just travel all around the world to come to us is immense. So we definitely want to look at that's one of the key characteristics of circular supply chain. Moving on, the next one is visible. So after we have leaned our supply chain out, we want to look at how do we make the circulation of goods possible. So the waste from one operation becomes value for the another. So circulating goods in the process, and every operation becomes a source of raw materials for the other. So who defines value for us right now? It's customers. So there's more value. Now that our waste has become value, we'll have more value. And if we have more value, there are more customers in a circular world. And now that we have more customers, we are actually looking at, in our value stream map, we think of value and waste. In future, we'll actually be thinking of them as primary and secondary value streams. And so waste wouldn't really exist. The third characteristic is predictive. And here, if we think about it, if we need to tell our new customers now where the material is coming from. If you look around, every single material right now around you has the potential to add value and to some other process and be able to be reused again. And so now this will start looking familiar, where right now our customers give us forecast and we have order horizons and we sort out how our supply should look like. Now, in our circular economy, we will have 2 value streams. So we'll have value stream customers and we have waste stream customers. And now it will become a delicate dance where we find out whose order is more important and determine production priority and, of course, the other factors that's important, while reducing the amount that's being used in the overall process. The next one is regional, which is very important to look at from a CE perspective. Is we harvest, transform, and use materials regionally. What you see right now here is a picture of Cape Town, and what they're trying to do is balance the idea of industrial symbiosis. Can we repurpose and harvest and transform materials regionally? And has lots of value. It could we can argue that it could be more expensive, and we could look at there could be multiple market failures that we could think about. But overall, if you look at the landed costs, it will actually work out better for us. And the final one is being flexible, where we are looking at range of materials and types and being flexible about the production to quickly switch among products and manufacturing lines that can handle both new and remanufactured materials. We also have to, there's a concept called biofactoring, and the research being done on that show that about 100 billion out of the 100 billion tons of materials coming in global economy every year, 60 billion of that could actually come from biology and not really from the raw materials or elements from the planet. That's super exciting, and we should be ready to be able to handle different types of materials in our operations and be flexible in terms of quality and what kind of materials and design that we are looking for our products that we are offering to our customers. Moving on to the next slide. I think Eddie will go over some role plays for us.
Perfect. Thank you, SNEHA. And now let's get into a couple of issues that we have now that in the future we won't have anymore because we'll all be in a circular supply chain by 2030. All right. So this is your boss. She comes to you and says, hey, guess what? Budgets are down. I think all of y'all have probably experienced this every year. We rarely ever get our boss coming in saying, congratulations, I've increased your budget by 25%. So how does this work? All right. So if we're in a circular supply chain, our CapEx will go down because we have a better handle on how to make items last even longer, whether these are forklifts or trucks or whatever the large capital equipment is in your life. CapEx goes down. Okay. And then OpEx also comes down because we've actually found a great source of secondary materials and we've joined up buying groups to drive market prices down, so receiving even more. So the materials coming into our circular supply chains are less expensive than they were before, so we're able to handle these budget cuts. And also, OpEx comes down even more because you found a way to cut your energy bill in your factories by 30%. You've changed some processes, you've used some math to optimize and figure out where you actually need to have different energy sources coming in. And for the first time in history, renewable energy is now less expensive in many parts of the world than traditional energy sources. This is really exciting, of course, because renewable energy falls onto that green side, renewable sources of energy rather than the finite sources of energy. And it's great because you're saving money. And yet again, you have found a buyer for the waste produced in your operation. So just right before you had to put it into the landfill. Now, somebody comes by and actually pays you to load up all of your extras out of your process that you couldn't lean out. There's always going to be waste at some point, but in a circular economy, that becomes a secondary value stream, and there's more customers out there. So last one to celebrate here is the cost of creating work comes down in a circular economy. I won't walk you through that today, but the math ends up something like this. We have three types of inputs into our processes. We have money, we have labor, and we have materials. So if we think about refurbishing something like a car, the amount of materials that goes into refurbishing versus building new is dramatically less. The amount of labor needed to refurbish is quite a bit more, which tends to turn people off the idea, but the amount of dollars going into the process is also quite a bit less. So the way it works out is the cost to create work is significantly lower. This means our supply chains can employ more people. I can't think of a single supply chain right now that wouldn't like to employ more people for less expensive. So your team is very happy. So here we are in 2030. And your boss, she's happy and she's saying that you have less budget, and we say that is no problem.
If you click next, Eddie, this is actually our sourcing manager, and he's concerned that the material costs are going up and no one seems to have enough supply. If you go next, and this will happen right now in our current state of supply chains, and this is exactly why we have to dramatically reduce our reliance on virgin raw materials so that we can have materials and we use less materials from our planet. And be able to use and reuse and extend the life of the commodities that we are using as a source of materials for our processes. In this picture, as you can see, it's not you could set up water sharing. So right now you're looking at sharing resources and energy, not just materials, with the nearby factories, and maybe use analytics, IoT, to reduce and understand your usage. Moving to the next slide. You could also look into flexible operations, so that can take different material quality and variation, so you have more options in keeping the line running, and be more flexible with the design of the products and operations as well. Moving to the next slide. Or we could also look into creating a take-back program where our supply chains can actually remanufacture in addition to the new items. And no, the robots will not be taking all our jobs by 2030. We'll actually need more labor because maintenance and repair labor is really needed, and it's a unique skill that is required by the workforce. Moving to the next slide, we have joined a pilot program to test an electric fleet to eliminate our dependency on petrol, which is also a fastest depleting resource as well. Going to the next slide. So based on these examples, material costs are going up, and this problem of material costs going up goes down because now we have identified another value stream, and make sure that the wastes are coming as inputs, and we are able to use and reuse our materials. So our sourcing manager is happy.
Awesome. So this is your logistics lead, and she is saying, gosh, we really have a problem. Nothing is clearing the port right now. And so we go back to our principles under the circular economy, and we find a partnership with a local scrap metal producer harvester. And of course, scrap metal has been harvested for many years now. This will start to become, this will start to become even more important as we start to retain the value in these metals for as long as possible. We have switched our operations using bioplastic made from local bioscraps. And again, this is already happening today. This will increase in scale and availability. The materials that we're producing will have quite a bit of innovation in the years to come. We've also done something quite new. You have taken your big mega factory and decentralized it down into shipping containers. You've put them very close to the point of use in order to harvest and use materials locally. Unilever has done this very recently. They call it their nano factory. Quite an interesting operation. They've put an entire manufacturing line within a 40-foot container, and you can drop these into the markets where you need them. We predict in the future we're going to have transportation that is split into two categories. We'll have value-added transportation, and we'll have non-value-added transportation. Value-added transportation might look like it's taking materials and processing them in transit, or even producing finished goods in transit. So we take this idea of a nanofactory and put it on wheels and have it produced in transit. Then we must move it around. At least it's adding some value. Hopefully it comes from an electric source that is made from wind or hydro, and so it could be a little cleaner as well. Where non-value-added transit, I think, will be very similar to what we have today. So you can go back and say, hey, no problem. That is the port. No problem that nothing is clearing the port. We are fine. Next. So this is your company sustainability leader. She's quite chuffed because transportation accounts for about 15% of global emissions. Your strategy of a short regional supply chain and electric fleet dramatically reduces your carbon input because you're more local. You've nearly eliminated the need for air freight, which is a huge carbon emitter. You have used better. Now, energy is about a third of carbon emissions. You've cut your energy use in your operations and switched to renewable sources of energy. So that's okay. Problem fixed.
All right. We will quickly look at how AI, artificial intelligence, would play a key role in creating smart circular economies. Moving to the next slide. There are four aspects that I would like to go over. The first one is actually customer returns. So how does exactly being like introducing artificial intelligence and augmenting that to understand what is being connecting our customers with the entire supply chain and understanding what sorting the return goods that we take from them that is coming from mixed material streams using AI and visual recognition techniques, which and assisted by robots, we could actually automate the disassembly of the products, and it will be based on the condition of the product. So you could take back a lot of value added materials from the customer returns and not just them and ending up in a waste bin. The next slide. The secondary material streams, I think we have spoken about this a lot in a previous slide. We definitely want to connect the consumers to our second-hand material streams. So like a database where sharing things and connecting them with people who actually want them, from it could be from tools to cars to houses, anything. Just bringing that full material stream together will be key, especially when we will be functioning in a circular economy. Moving to the next slide. We're talking about product design. Actually, circular economy starts with product design. We have to design for circularity. What AI does is it's good at performing specific, well-defined tasks normally associated with human cognitive abilities, such as voice recognition or trend prediction and pattern spotting. And AI can actually help us design products using secondary materials and also have algorithms that could look at mass data sets of materials and can actually connect that with customer preferences or customer demand at the time. So it works out both, not only just for our economy overall being circular, but also the business, because we are trying to meet our customer demands. The last one, moving on, is actually predictive maintenance. And products at their end of life are not as uniform as they were when they were first manufactured. So it's harder to automatically just disassemble, sort, and separate. And this is where we could actually use intellectual robots to understand their condition, where exactly actually being able to inspect and then treat based on where the faults are. That will help us extend the useful life of the overall machinery or product or whatever we are working on. Moving on to the next slide.
Perfect. So let's really go for it. 2030. I want to explain just a couple of more imaginative, bolder visions where we see the world going. The future of manufacturing is one that will be mobile. Today, even if you don't own your own factory, you're probably working with a contract manufacturer and you own the capacity. It may as well be your own factory. You've got a lot of control over how the lines are set, what goods look like, and the work instructions. You might even have visibility into real time what's happening on the line. The future of manufacturing, I imagine, will be a network of manufacturers around the world. So imagine just as you drop an order to a logistics network today, imagine you can drop an order into a manufacturing network and the routing or the order management behind that will look something like what is being built and for which market. How close to that market can we get? How many do we actually need to produce? And these factories of the future will be quite smart. They can change over not only to a different product of the same company, but to a different company. So you may drop in a clothing production order into a textile network. Food and beverage will be shared among competitors. And we can start thinking about this type of thousands of factories around the world that you can take advantage of. Lots of benefits to doing this, of course. If we think about the principle of circular economy, you can use less because we're going to drive up the utilization of all those lines. Not every line is run 24 hours a day because it doesn't need to be, because we're keeping items for ourselves, just like we think about how often our car is parked. This is happening with factories around the world in our supply chain. The second principle is to keep items in use for as long as possible. This allows us to do that if we're all coming together around the same set of manufacturing assets. This also gets our items as close to the point of use as possible, so we don't need to be shipping items around the world anymore. We certainly need to get those raw materials which should be able to source regionally. And then we are producing items as close to the point of use as possible. We'll recall also that much of the manufacturing in the future won't be these new builds. That's kind of zooming towards the point of sale. Instead, in the circular supply chain, the point of sale is the beginning of the story. And the majority of the work we're going to be doing is actually remanufacturing fixture for us. So if we can pull this off, this idea of mobility going, we can come down to a lot size of 1. So this model is the transition model the team at Circular Supply Chain Network have come up with, and with the help of supply chain professionals all over the world. This transition model, which is divided into 7 strategies, shows a way how companies can move from a linear to a circular supply chain. So we touched on circular supply chains with SNEHA, but let's see what the real actual definition is. So what is a circular supply chain? Circular supply chains are interconnected systems that use secondary renewable inputs to generate value by reducing and maximizing resource use. So let me briefly explain how you can apply these 7 steps to your company, or just start thinking about it now. So the first one, we start with identify. Find and define what materials, resources move through your process. Intensify. Think about how you could increase the utilization of materials so they add the highest value possible. Narrow. Think about how your company could reduce the number of resources needed. Then we move to predict. Try to predict when, where, and how, and what resources are ready for others across the supply chain network to use. Then we move on to slow. Think about how your company could elongate the life of products. Close. Would it be possible to only source secondary or regenerative materials, resources for all processes in the supply chain? And last, capture. Locate and transform secondary materials that are available and affordable for supply chain operations, and then put it all back in, and it just is this endless loop. And so we call the circular supply chain.
Thank you so much, Eddie. And so we spoke a lot at length about what circular economy and supply chain looks like. And imagine taking all those 50 sources and 50 suppliers down to 1. Your assembly processes are reduced. You actually now are co-located. Your factories are near. Your overall route has gone down because your materials are not traveling across the world. Imagine living in a world where you do not have a forecast. Yeah, it sounds weird and crazy, but we will actually live in a world where we do not need forecast, with zillions of nodes in our supply chain will now not go through obsolescence, because every product has now every product now is not in a waste form, but in a value form, and actually as an input to every other process or industry. And this will immensely reduce our pull on our planet. And we have to also look at, putting our production very close to each other. And so will it happen? Well, we'll find out in 2030. Our supply chains are complex enough. Let's imagine a future where the complexity and the effort and all the math that we're working on goes towards building something that matters. We are super glad to have gone through. We are exactly at time, but definitely want to go over any questions you might have and be able to answer them. Hi, Jenny.
Hello, nice to meet you in public for the first time. But from my point of view, thank you so much. Thank you for the early start. Your time, is it even light yet?
Well, I am in Pacific Coast. I think both of us are no light yet. It's still 5 a.m.
But thank you so much for doing that, and thank you for sharing it with us. And it's really exciting to see. I'm going to call you next gen circular economy enthusiasts, and I think that Deborah's doing a great job in stimulating this sort of skill set and helping you to channel all your knowledge and everything else. There are a couple of quick questions. We are running over. So if they can, I'm going to do one quick one from Scott, which is, will supply chain be an even bigger talent magnet in 2030? Yeah, go for it.
Yes.
Yeah, absolutely. I mean, nowadays supply chains are getting talked about even more than they were before. I'm going to be a soon graduate here from the university, and it's what's all the fuss about in the business school. Everyone's talking about all the opportunities in supply chains, especially now that sustainable supply chains is a big topic, and so now everybody's really merging that sustainability field with supply chains, and it's just such a whole new exciting field. Mm-hmm. So I do believe that it's going to be a huge talent magnet in years to come. So
yes, absolutely, Scott. Thanks for that question. And I guess we know that supply chain is hot right now, and it will remain this way. And as we went over, supply chains will be very key, important aspect to make circular economy possible. And as we see the shift for many industries towards, making conscious decisions, improving the way that we manufacture and produce goods today, the need for supply chain professionals and that skill is very important, and it's only going to increase from today.
Absolutely. Well, thank you for that. I'm going to cut it now. But Zenola, you've asked a question about fostering cooperation between companies. Let's get so this is Zenola Moodley. So you can find her in the attendees, and you can make a plan to connect with her and answer her question. And then she can share it, and we can all see, and we'll all learn. But really, thank you so much. I hope that you can hang around for a little bit, maybe for the rest of the day. You're welcome to stay for as long as you like, and then grab a seat at the lounge, and people can try and find you afterwards. They can also go into the speaker section and send you messages directly there too. So thank you for pushing the push and keeping helping us all, hopefully, eventually, to keep the lights on, and for educating people like me too. So thank you very much.
Thank you so much for this platform, Jenny. I just absolutely enjoyed being here. Thanks a lot.
Yeah, thank you for having us. Appreciate it.
Great. Here's to next year. We'll see you in Cape Town, hopefully.
Absolutely.
Hopefully. Oh, would love to. Yes.
Bye-bye.
Okay, thank you. Thanks everyone for listening, and choose your next slot and on to there. But thanks very much, you two.
Thanks. Bye.